Well, hello guys, Mr. G here, and as promised we are going to be doing another video on velocity and times graph. This time it's going to be a question or two questions. We're going to do two questions related to velocity versus times graph. Okay, the first question says a boy throw a ball vertically into the air from top of a building. The ball strikes the ground after 4.08 seconds. The velocity versus times graph below represents the entire motion of the ball. Ignore the effect of friction. And here we can see the graph. Okay, so if we look quickly before we keep reading, remember the person that threw the ball was not on the ground, it was on a building, and then he threw the ball upward, and obviously the ball is going to fall all the way to the ground, okay, vertically upward, right? So this is important to know and to note perhaps if we need it for the question. All right, so that is important. Now let's go to the questions quickly. Explain what it means by projectile, what is the acceleration of the ball at 1.02 seconds, calculate the displacement of the ball, and sketch the position versus times graph for the entire motion of the ball. Indicate the following in your graph, and I give you a list of things that must be on the graph. So let's first of all answer the question 1.1. Let's write question 1.1, and question 1.1 is the definition of projectile. So what is a projectile? It's any object. Important is an object, okay, that move under the influence of gravitational force only. The only force that act on the object is the gravitational force. It's the only force acting on the object. So this is what is a projectile, and it's question 1.1. Question 1.2, what is the acceleration of the ball at 1.202 seconds? And that it does not matter where do they ask you for the acceleration of the projectile. The projectile is moving under the influence of gravitational force only, so the acceleration through the entire motion is going to be 9.8 meters per second square downward. So you must write the direction, okay? People attempt to forget the direction and they will lose a mark in the exam. It's downward. The actual direction is towards the center of the earth. We already spoke about this, but for now downward will make it right. So that is important, and it's not only in that specific point but the entire motion. Now not at that point they ask you, which is right here, the object is at its maximum height. This one is h maximum, and because the velocity at that point is equal to 0, children or learners or people attempt to forget or confuse acceleration with velocity, okay? So please, the acceleration is 9.8 meters per second downward during the whole motion. At the maximum height, the velocity is 0, but the acceleration is still going to be 9.8 meters per second downward. So if we look here, right there, the acceleration at that point will be g, which is 9.8 meters per second square downward. So that answer question 1.2. Question 1.3, calculate the displacement of the ball. Now the displacement of the ball, and I'm going to use the picture I already explained in previous videos, and this is quite important. When the object was moving, and I'm not going to look at the graph, I'm going to be looking at the picture here on the left side. When the object was moving, this one here was the initial position of the object, which was the release point, or the point where the object was thrown. The final position of the entire motion is right on the ground. That is the final position, and the displacement is the vector that is going from the initial position to the final position. So the displacement of the object is this one here. That represents the displacement of this object. It doesn't matter if it's going up before went to the final point. So now if we go to the graph, we need to take the data from the graph. The initial velocity of the object is this one here. This is the initial velocity of the object throughout the whole motion, and it is positive. The object was thrown up. It means that up was positive in this specific question. All this one we are talking here is important before you go to solve the question. Now what does the object do? of the projectile move all the way down here at this point, and we say is at the maximum height, the velocity is 0. Then it turns down all the way, that is why down is negative, and here this is the velocity of the object just before reaching the ground or before touching the ground, that final velocity. The total motion of the total time of the whole motion was this one. This is total time for the entire motion. So everything is given in the graph. You don't have to struggle. Let's write down the data anyway, because we always do it, and this is question 1.3. 1.2 was the acceleration. So let's quickly write the data. Okay, and here is the data. Note, up is positive, not because I say that, it is because it is in the graph like that. The graph up show you that up is positive, okay? So now let's look for the formula that best can help us and calculate the displacement. The formula that best can help us is displacement is equal to initial velocity plus final velocity divided by 2 multiplied by the time. So we substitute. Guys, this is the calculation of the displacement. Now, to finish, they want to know, or they want you to sketch the position versus time graph for the entire motion and indicate the following in your graph. So let's write the axis and let's take the ground as a reference point. Okay, so this is the axis. Now let's first of all draw the graph roughly without adding any numbers, and then we're going to add the numbers. Remember, there is a video for graph of position versus time, so please go and watch it. The object was some height already from the ground and it was thrown up. So this object moved all the way up to certain height and is going to return to the point from which it was drawn. So this is what happened, but the object doesn't stop there. The object continues moving all the way to the ground, right, as time passes. So if we go there, let's first of all write down what we know from the previous graph. For example, the total time here, the total time of the object is given, and that one is say 4, let's write the number 4,08 seconds. If you go to the other graph, to the graph of velocity, which is the one that is the total time, but this 0,2 is the time it takes for reaching the maximum height. So let's add that one as well. Now in this graph, the maximum height will be right there. This will represent the maximum height, and therefore if you come here, this is the time it takes for the maximum height, which was 1,02. That was 0.2. That was the time taken to reach its maximum height. So this is what we know for now. Now let's see what else are they asking. The displacement. We have the displacement. They ask to initial position. Now initial position, remember, it was from where the object was thrown. So here, which is also coincident with the displacement, is the initial position of the object, and it is 41,58 meters. So that is the initial position of the projectile. Maximum height. Now maximum height, note, it is not shown in this graph and they want us to find it. Therefore we have to calculate the maximum height before we add it into the graph. So what data do we have to calculate the maximum height? Let's write it on this side. We have that the initial velocity is given to us, which is 9,8 meters per second upward. Okay, remember, up is positive for the entire motion. The final velocity is going to be 0 because I'm talking about the maximum height. This is at h maximum. We have the time that took to reach the maximum height, which was 1,02 seconds, and we know the acceleration due to gravity, which is minus 9,8 meters per second squared. Please do not forget the minus there. So what formulas can help us to calculate the maximum height, the displacement, we can use in fact the same formula we used just now before, which is displacement is equal to initial velocity plus final velocity divided by 2 multiplied by the time. And if we substitute, the answer is 4,998 meters. Now note the following. This answer is the distance from release point to maximum height. So the maximum height here at this specific point on the graph is not going to be 4,998. It cannot be. It will be the addition of 41,58. So let's write it here, 41,58 plus the 4,998. That is the value that is going to be here at this point. So let's calculate it, and the answer is 46,578. That is the maximum height of the object. So what else is what else must be in the graph? Final position. The final position of the object is 0. That is important. And then what else is asking you? The time values. So the time values are all given there. That is the time to reach the maximum height. This is the total time. So this is the first question, guys. I hope you understand. It is not that bad. Let's go to the second question, which as usual is going to be a little bit more tricky. This question is going to be a bouncing ball. Okay, so now question 2 said a man throws a rubber ball vertically upward at speed of 4,9 meters per second from a balcony of a building. When the ball lands on the ground, it bounces vertically upward. The velocity times graph below represents the motion of the rubber ball, and it's almost the same as the previous graph, as we can see here, but if the object is going to bounce, so it should not be a problem because it's almost the same. So this is the graph. Now 2.1, write down the definition of a free ball. 2.2, use the graph to determine the time it takes for the ball to reach its maximum height once thrown upward, the time at which the ball strikes the ground for the first time, and calculate the speed of the ball after 0.3 seconds of being thrown. And the last one, say the ball loses 10% of its velocity when it strikes the ground. Calculate the height to which the ball bounces after striking the ground. So let's start with the definition of free fall, and it's almost the same as projectile. Alright, so free fall is the motion, and we have to highlight word motion. Previously, remember, projectile was an object. This is a motion of an object where the gravitational force is the only force. Gravitational force is the only force acting on it, on the object. Okay, this is the free fall, and it's almost the same as projectile. So that is the first question. Question 2.2.1, determine the time it takes for the ball to reach its maximum height upon it was thrown. Now, from the graph, this here is the time it took at the maximum height. When the velocity is there and the time is there, the object is at maximum height. This one, please watch the video. If you think you're going to get confused, you can notice that the object was thrown up, the velocity decreases up until maximum height, so the velocity at the maximum height is equal to 0. Alright, now the question is about the time. So the time is 0.5 seconds. We can answer here, we're not going to write at the bottom. The time was here equal to 0.5 seconds. And the time at which the ball strikes the ground for the first time. So the first time the ball strikes the ground here, this dotted line means that the ball strikes the ground. So it was at 1.5 seconds. So time is equal to 1.5 seconds. That was the time when the ball reaches the ground. Calculate the speed of the ball after 0.3 seconds of being thrown. 0.3 seconds, it is going to be right here. So they want to know what is the velocity of the object at that time. The time is 0.3 3 seconds according to the question. So let's calculate that question, and that is question 2.3. okay, so question 2.3, let's write the data we have, and please note that all the data is in the graph. Okay, so with this data, the best formula to use is the final velocity is equal to initial velocity plus acceleration multiplied by the time. This is the best formula to use here. And this is the answer. They're asking you for the speed, so we don't have to give direction. So this is the answer for that question. So let's go to the last question. Now the last question is not that difficult, even though you see a percentage there. They say the ball loses 10% of its velocity when it strikes the ground. Now, when the object strikes the ground, the velocity is going to be this one here, which is going to be 9.8 downward. That is the velocity with which the ball strikes the ground. And now it says that it loses 10% of that number, so it's not that bad. Let's see the data and let's find out what it means that 10% of the 9.8. This is question 2.4, and now let's start from there. The velocity when strike the ground is 10%. So how I do this in mathematics? I said that 9.8 is 100%. Okay, this is how to convert it, or how I do convert it. Then 10%, how much represent of that 9.8? And when you do the cross product here, it will give you the amount. So this one is going to be 100x equal to 9.8 multiplied by 10. And this will give me that x is equal to 0.98. Now, note the following. The velocity of the object is not 0.98. That's not the question said. The question said that it loses 10% of its velocity. 10% is the 0.98. So the initial velocity of the object when it leaves the ground is the 9.8 minus the 10%, which is 0.98. So this is the initial velocity of the object, which is upward. And remember, for the whole motion, up is positive. It is in the graph. I cannot change that one. Let's perhaps write it here somewhere. Yeah, up, positive. I cannot change that one. All right, now, therefore, the initial velocity is this number, which is going to be 8.82 meters per second. So this is the conversion of that 10%. It's not that bad. It was just a tricky one. Perhaps it's just to intimidate, okay? But it's not that. But now, let's read quickly, because that is obviously not the question. The question said, calculate the height to which the ball bounces after striking the ground. So they're asking you to calculate, let's say, the displacement, which is the maximum height of the second bounce, okay? So the displacement will be question mark. What else you have? The final velocity is going to be 0. This is at h maximum, okay? It's going to be 0. And the time is in the graph. So it's in the graph, which is going to be 2.5 minus 1.5. That is the time. Be careful. This question is not that bad, but it could be confusing. And that is equal to 1 second. So saying that, what would be the best formula to substitute or to use in this question? Well, I think the best one is to say that the displacement is equal to initial velocity plus final velocity divided by 2 multiplied by the time. So the ball reached a height of 4.41 meters after the first bounce. And height is a scalar quantity, so we don't have to give direction. Okay, guys, this is the questions. I hope it helped. This is the 2 questions we did. Next video is going to be the experiment to calculate the acceleration due to gravity. As usual, thank you for watching, thanks for supporting, thumb up if you think it's nice and help you, and I'll see you next time. Mr. G here.